IoT network consists of structured configurations where nodes are organized hierarchically. The term IoT network topology refers to the arrangement of the IoT devices within the network. This layout of devices, known as nodes, determines how they communicate and how data flows among them. The selected topology influences the network's performance, reliability, scalability, and overall cost. There are known networking topologies and their specific applications. Every topology has advantages and disadvantages, which we'll briefly focus now. In a star topology, all devices are connected directly to a central hub, also called a gateway or an access point. This hub is a network's communication and coordination central point. The nodes are within the radio propagation of the hub. The central hub handles all communication between the nodes. Star topology is most common in home applications, particularly for Wi-Fi wireless Internet access points. Advantages include simplicity, failure isolation, ease of management, and low latency. Disadvantages are single point of failure, scalability limits, and distance constraints. A tree-network topology organizes devices hierarchically, with the root node at the top and other devices forming branches at multiple levels. It is a structured extension of the star topology where specific nodes function as routers for additional nodes. If one of the router nodes fails, the entire branch it supports is disconnected from the network. A very particular example of such a network is Bluetooth scatternet. Advantages include scalability, data flow hierarchical organization, and distributed data processing, example aggregation. Disadvantages include dependency on the higher-level routing nodes and complex setup and maintenance challenges. In a mesh topology, each device is interconnected with one or more devices, creating multiple communication paths. Thus, mesh networks can be partial with only some limited connectivity among nodes or full where all nodes are interconnected. Each node in the network has at least two neighbors to which the packets can be transmitted. A mesh network can have multiple gateway points connecting the mesh with an external network or networks. Advantages include high reliability because there are multiple routing paths, so if one route fails, there are backup ones. Other benefits are self-healing, scalability, automated load balancing, and optimal coverage of physical areas. Disadvantages include higher complexity, higher costs, more complex network stack implementation on the software level, and frequently energy-intensive communication demands. Linear topology connects devices sequentially, linking each node to its immediate neighbors. A variation of this topology is a linear topology with redundancy, which allows each node to connect to its two adjacent neighbors, both in front and behind. The setup provides backup routing capabilities in case one of the nodes fails. In linear topologies, all nodes except for the last one must be capable to function as data relays. Advances include simplicity with straightforward and cost-effective setup, ease of expansion across one dimension, and selected applications of linearly aligned setups such as pipelines or conveyor belts. Disadvantages include high and variable latency that depends on the data origin position in the line, limited scalability, and a single point of failure that is particularly resolved by redundant linear networks. All devices share a common communication backbone in the bus topology, and data is broadcast across the bus. Advantages of the bus topology include cost effectiveness, easy implementation, and low data collision. Disadvantages include complete backbone dependency that causes the whole network to be down in case of the bus failure, performance limitations, and troubleshooting challenges. In a ring topology, devices are arranged in a closed loop, allowing data to travel around the ring in one or both directions. Advantages include consistent performance and latency, fault tolerance for bidirectional networks, and predictable data flow. Disadvantages include failure sensitivity, increased latency with the ring size growth, and inflexibility in the network extension. Hybrid topology merges multiple models as mentioned earlier into one. A customized hybrid network topology model can be tailored especially for particular application and related requirements. The advantages depend on the exact model merged, but most of all, it brings excellent flexibility. Disadvantages include high complexity, cost, integration issues, and the need to craft a dedicated solution including design, hardware, software, and procedures. Selecting the proper IoT network topology involves carefully assessing the application-specific needs such as reliability, scalability, costs, and energy efficiency. Frequently, IoT deployments utilize a mix of technologies to enhance performance across various requirements. It is crucial to understand the strengths and limitations of each technology to design effective IoT networks.